All right, so welcome to Nearpod lesson 4.5, electron trends or patterns in the periodic table. So this is a general reminder to make sure you have titled your notes as it says here. And these are the 3 things you need to know from today's video. So the last time we talked about salts or ions, we know that all salts or ions have a charge and we need them to survive. Otherwise, we get cramps or headaches and things like that. And particularly, these are the 5 ions that we need in our body. And in our last 2 lessons, we talked about how do regular elements end up with ions. So currently, we only can tell whether a patient has too much or too little of certain ions based off of their symptoms. And if you notice, the symptoms are very similar to each other. So it's kind of hard to figure out for sure which ion you have too much or too little of unless you have a more accurate test. And I can't tell you or create that accurate test with you unless you know a little bit about the periodic table and how ions relate to the periodic table. So we're going to take a break from ions a little bit and learn a little bit more about the periodic table so we can develop a test to figure out whether a patient has too many or too little of certain ions. So here we have 2 things we need to know about the periodic table, that anytime we call something in the periodic table a group or a family, those are elements in the same vertical column. So notice that all of these elements in red are in the same group or family. All of these elements in orange are in the same group or family. If I was looking at an actual periodic table, right, I'm talking about all of these elements are in the same group or family. Right? And then all of these ones underneath the number 2 and 2a, these are in the same group or family. Sometimes they're called group, sometimes they're called family. I will probably call them a group because that's just what I've been taught and what I'm used to. Okay, so another thing you should know is that elements in the same group have the same number of valence electrons. So before, when we had to figure out how many valence electrons an element has, we kind of had to draw it out to see how many valence electrons. And by valence electrons, I mean electrons that they have in their outermost shell. So if you've forgotten that, go ahead and add to your notes that when I say valence electrons, I'm talking about electrons in the outermost shell. And if you don't remember what a shell is, I'm talking about the rings, right? So let's go over this. So if I go onto the periodic table, here's like a smaller version of the periodic table. And if I look at all of the elements in group 1a, I'm going to notice that they all have one valence electron or one electron in their outermost ring. So to double check that, when I say group, we're going down, right? So in group 1, there's one dot or one valence electron in red that I'm going to color in blue. Here, this next one below, also in group 1, one valence electron. Na, also in group 1, one valence electron. So I don't need to draw out the atom anymore or show you a picture of the atom. You can just look it up on the periodic table. If that element is in group 1, it will have one valence electron. If it's in group 2, it will have 2 valence electrons, so on and so forth, all the way down to group 8. Right? But I will say that in group 8, there is an exception to the rule, so that's why I underline this part. So in group 8A, most of the elements have 8 valence electrons except for helium. So helium here, notice that helium is the only one that doesn't have 8 valence electrons. It only has 2 because it only fills up the first ring, right? And in the first ring, we can only fit 2 valence electrons. So definitely make sure you write down this particular exception in group 8A. So everything written in red, I would write this down. Feel free to shorten this part though. Right? So something I might ask you just to practice a little bit is if I give you this periodic table, we're going to switch over to this periodic table because it's a little more simplified, right? If I ask you, okay, carbon has how many valence electrons? Well, if I look up, carbon is in group or column 4A or the family 4A. So therefore, carbon's going to have 4 valence electrons, right? It's kind of like nice that way. How did I know that? Because the trend or pattern is that in group 4A, they have 4 valence electrons. And if I check here, carbon has 1, 2, 3, 4 valence electrons, right? Pretty straightforward. So something else you should know about the periodic table is that elements that are in the same row, we call them a period. So a period goes across, right? So if I'm in the first period, this is all the red elements. Second period or period number 2, I'm looking at all the elements in orange, so on and so forth. So period number 3 would be all the ones in yellow. So a side note or a pattern within each period is the number of rings and shell that they have. So a neat thing that you should know that you don't have to look up anymore is that elements in period 1 will all have 1 ring where the electrons fit. So you might notice and say that, hey, Ms. Kwan, I see 2 rings or 2 circles. Remember that this first ring is the nucleus. And so the second ring that you see with the dots, that's red, this is ring or shell number 1, right? So this ring is the actual ring. The first ring is the nucleus. So if you're in period 2, it's going to have 2 rings, 1, 2. If you're in period 3, it's going to have 3 rings. Okay. So one of the last things you need to know in terms of patterns in the periodic table is that elements that are in the same group also have the same charges. Right? So notice that elements in group 1A all have a charge of 1 plus, 2A has 2 plus, and then you might be wondering that so far in this video, I've kind of been ignoring these. And that's because their charges get kind of weird. Same with their valence electrons. There are a lot of exceptions to the rules. So we're just going to pretend that this middle part here that isn't colored doesn't exist for now. And then we'll get back to it later once we learn the basics. Right? So group 3A is going to have a charge of 3 plus. 4A has a charge of 4 plus or minus, so on and so forth. Right? So the pattern kind of goes like up and then down. So it's like 1, 2, 3, 4, and then 3, 2, 1, 0. And as I'm going down, it becomes negative, right? So it's positive 1, positive 2, positive 3, plus or minus 4. Think of this as like the same thing, right? We won't really be using this too much. Minus 3, minus 2, minus 1, and then no charge or a charge of 0. So you might wonder, why does group 8A not have any charge? Well, if you think back to the previous slide, remember that in group 8A, we have 8 valence electrons, right? And the goal of elements becoming ions is to get a full ring or full shell of electrons. And if we look at group 8A, they all have 8 electrons or a full ring or shell already. So they're not going to want to lose or gain any valence electrons, right? Even helium that has 2 valence electrons, that first ring only fits 2 anyways. So it doesn't want to get rid of any electrons, nor does it want to gain any electrons because it already has a full ring. These elements tend not to want to have a charge or become any ions. So going back to the patterns in ion charge, know that this is the general pattern for ions. I just think of the order is 1, 2, 3, 4, and then back down 3, 2, 1 with the minus charge and then 0. This one's kind of a little bit trickier. I would definitely have this part's written in red just to help me out in my notes. Or if it helps you, I tend to like to draw it out better like this. This is my personal preference, but definitely have this down. Okay, so let's do some practice problems with what we know. Right, so one of the problems that you'll see is I might ask you how many valence electrons would the following elements have? Right, carbon C, potassium, calcium, blah, 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 all of these. Right, so in order to solve this, we're going to have to first go to the periodic table. So normally I have you go to ptable.com for the periodic table, but we're going to use a little simplified version of the periodic table. And if you go to tinyurl.com/quanptable, it will take you here, the periodic table I was using earlier. So in this case, right, this tends to be the periodic table that they give you for school state testings. So just so you're more familiar with this one, this is the one that we're going to use to help us identify things. Plus it has like a couple of extra numbers that are more helpful in chemistry than ptable.com. Right. So if I need to look for carbon and how many valence electrons carbon has, I'm going to look for carbon on the periodic table first. I'm going to look for carbon. Where is it? Oh my gosh, it's right there. So carbon is here. And again, I kind of covered it up, but it is in group 4A. So therefore, it will have 4 valence electrons. Right? So carbon's going to have 4 valence electrons because it's in group or column 4A. Well, what about potassium? So to find potassium, let's do that one in a different color so you know that we're on a different problem. So potassium, I'm going to look for the element potassium going left to right. Since I have these memorized, you kind of know where they're at. Potassium is here, element number K. Right, so if I look up at the group number, aha, it is in group 1A, so therefore it will have 1 valence electron. Right, go ahead and pause the video and see if you can figure out the rest of these. The trickiest one here is helium, and then unpause when you're ready, and I'll have the answers ready for you. Okay, so these are our answers. So if you looked up calcium, it is in group 2A, so it's going to have 2 valence electrons. All right, calcium Ca is here in group 2A. Right, fluorine is going to have 7 valence electrons. Box this one so you know what the answers are. 7 valence electrons because it's in group 7A. So fluorine is here. Here is group 7A, so therefore it has 7 valence electrons. Neon is going to have 8 valence electrons because it's in group 8A. So neon is here. It is under group 8A, so it has 8 valence electrons. Helium is going to have 2 valence electrons, because remember, this is our one exception to the rule. Helium has 2 valence electrons. You just kind of have to know this one, right? That it is in the first row, super tiny. That first ring only fits 2 valence electrons anyways. So that's that. So what if I ask you instead, what are the charges of each element below? Right? So same thing as usual. You're going to find the elements using its name or its element symbol on tinyurl.com quan p table. Right? And then you're going to use the group number to help you identify the charge pattern. So something that I would recommend is that if you can, to go ahead and print this out for yourself. And when you print this out, what I used to do when this was all new to me, I would add the number 1 plus, 2 plus, 3 plus, 4 plus minus, 3 minus, 2 minus, 1 minus, and 0 on top, right? So this kind of thing that I did helped me find the charges a lot faster when I was still new to identifying the patterns in charges, right? It just helps me a lot more. But if you don't have a printer, it's okay. You would just have to use your notes on the side, right? Okay. So what are the charges of each element below? So here, I'm going to look for carbon again, and then I'm going to find its group number, and that will let me know the charge. Right, so let's do this in different colors so you can show that I'm working on this problem. So carbon, as before, is right here. It is in group 4A. So what is the charge going to be? Well, it's going to be plus or minus 4. So 4 plus or minus, meaning it can either donate 4 or lose 4 electrons, or it can gain 4 electrons. What about potassium? So let's look for potassium. Potassium is here. It is in group 1A, so it's going to have a charge of 1 plus. What about calcium? So if I look up calcium, Ca is here. It is in group 2A, so it's going to have a charge of 2 plus. So at this point, see if you can solve the rest of these 3 on your own, and then unpause to reveal the answer. All right, so hopefully you got a charge of 1 minus for fluorine because it's in group 7A. Neon and helium are both in group 8A, so their charges are going to be 0. So at this point, you should be able to use the periodic table in order to identify either the number of valence electrons an element has or its charge.